go, recording. So I've got root x, or sometimes it's written with the actual 2 in there. That little 2 there is called an index. It tells you what kind of root you're taking. If there is no index written, it is assumed to be a 2, because taking the first root of something makes no sense. It's not something we do. So the reason why roots and exponents are similar is this. Like if you take a look at what we've got here, if I had 4, if 4 is my x, and I want to take the square root of 4, the square root of 4 is 2. Why, Marcus, is it 2? Yeah, because 2 times 2 is 4. So the square root, hey, guys, what's going on?
I was washing my hands and I got water in my hands because I freshly burned it.
You washed your hands so aggressively that you burnt yourself.
No. I burned it in like woodworking. So like water went inside.
Nice. That's not a bad thing. Find this page in your notes. Okay, so the square root of 4 is 2 because 2 times 2 is 4. So the question is like, so if I'm squaring something, multiply it by itself. Square rooting is what times itself. Raven, stop talking across the class. You're not? Okay. He's wiping his face? Okay, I'm sorry. We have alternative notation for this. You can write it with this root sign that you've seen before, or you can actually write this as an exponent. If we use fractional exponents, I know fractions are coming back, x to the 1/2 is the same thing as square rooting something. What that means is what times itself gives you this number, whatever this number is. So the square root of 9 is, the square root of 16 is, I'm sensing a pattern, the square root of 25 is 6 and then 7. Okay, so we have a name for these kind of numbers. What are these numbers called? Does anyone know what these numbers are called? These numbers are also whole numbers, but I didn't circle these numbers. I just circled the top numbers. We have a name for 4, 9, 16, 25, 36, 49, 64, 81, 100, 100 perfect squares. These perfect squares can all be found on the diagonal of your multiplication table. Because the diagonal is always the number times itself. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, all the way down to 20 times 20. And in fact, for reasons that are going to become apparent here in a second, my A block class and I added the 21 by 21 is 441 for reasons that will become obvious in a couple minutes. So we call these numbers perfect squares. They're called perfect squares because they have square roots. Now it says here a perfect square root, or actually I'm going to get rid of this root here. The perfect square is finding a whole, is finding a whole number integer that multiplies by itself to give that original number. And it's not just integers. These can actually also be certain fractions, can also be certain decimals. You can have perfect squares without necessarily having integers, which is interesting. Now, perfect squares came from, the reason we call them squares is when this was first developed by the ancient Greeks, because that's who developed this stuff, they were using literal shapes, literal squares. This square here has an area of, well, let's count up the squares. There's 1, 2, 3, 4 squares. So the area of this entire square is 4. The area equals 4. Now, how do you find the area of a square? Yes. Yeah, but what is special about a square with the length and the width? They're the same. So this is going to be a length times a length. And with a square, those happen to be the same number. So in this case, if the area is 4, that's your perfect square. It's a square with an integer side length. The length of the square is what we call the root of the square. So when we're looking for when square roots were first developed, what they were literally looking for was, what is the side length that will give me a square of a certain area? But that's kind of a convoluted, gross way to think about it, which is why I don't necessarily teach it that way at the beginning. So this square has an area of what? How many squares are there? There's 9. 9 squares that are 1 by 1. So this thing has an area of 9. So what's the side length have to be? 3. Because the root of 9 is 3. Or what is the length of a side of a square with an area of 9? It's a lot wordier of a way to say that. And of course, this square represents, which has a side length of 4. Okay, cool. We can apply these idea of perfect squares and square roots to fractions and decimals. Let's take a look at these. If you recall how to multiply fractions together, dang it. Is 9 over 16 a perfect square? Some say yes, some say no. Those of you who said yes, why? Because 9 is a perfect square and 16 is a perfect square. So 9 is the same thing as 3 times 3. And if you remember how to multiply fractions, remember, we multiply numerators, we multiply denominators. And 16 is the same thing as 4 times 4. So 9 over 16 is the same thing as 3 over 4 times 3 over 4, something multiplied by itself. So that means that this thing must be a perfect square. And that is true because that guy is a perfect square. We're going to write perfect square a lot today. And that guy is a perfect square. Perfect square, I'm going to soon abbreviate it to PS. Okay, how about the next one? Is 144 over 36 a perfect square?
Yep.
Well, is 144 a perfect square? Can you find it on the diagonal of your number line or your multiplication table? Yeah, it's 144 is 12 times 12. So the square root of 144 over 36 is going to be 12 over 6, because 36 is 6 times 6. What is the cardinal rule of fractions? Who said reduce? Someone said reduce? That is correct. Reduce them. So what's 12 over 6 equal to? 2 over 1, which I can just write as 2. That's interesting. If the square root of 144 over 36 is 2, what does 144 over 36 have to be? Not only a perfect square, what perfect square? 4. This is the same as the square root of 4, which means that 144 over 36 must also equal 4. That's interesting. Let's take a look at the next one. How about this one? 4 and 9/16. Is that thing a perfect square?
Yep.
Are you sure? Now you're unsure. Okay, what's the first thing we're always supposed to do with mixed numbers? Make them improper. So 16 times 4 is? Riel's got a multiplication table in front of her. 64 plus 9 is? Thank you. So this thing's going to become 73 over 16. Is that a perfect square? No. Even though 4 is a perfect square, 9 is a perfect square, 16 is a perfect square. 4 and 9/16 is itself not a perfect square, because when you convert it to a fraction, the numerator isn't a perfect square. They have to both be perfect squares for the whole thing to be considered a perfect square. So this one is not. No. How about this last one? Let's move into the world of decimals, shall we? For a second, I'm going to go over here to the board, and we're going to write something down. There's some examples here that I don't have room for on the page. Okay, this requires you to remember how we multiply decimals together. I would like you, Juno, to give me a simple, just a simple decimal. The simplest decimal you can think of. Is your name Juno? 0.4. Okay, cool. I'm going to take 0.4, I'm going to multiply it by itself. How do you multiply decimals?
Move the decimal.
Okay, ignore it. Okay, and then 4 times 4. And what do I do? Because 0.4 times 0.4 is not 16. 4 times 4 is 16, so how do I bring the decimals back to my final answer? When we add and subtract, we bring it down. When we multiply, we don't bring it down.
You have to move it 2 spaces.
I move it as many spaces as there are decimal places in what I multiply. So there's 1 decimal place here, there's 1 decimal place here, 1 decimal place and 1 decimal place is 2 decimal places total. So in my final answer, I need to move the decimal place in twice. So 0.16 is a perfect square because it's 0.4 times 0.4. Cool. Eeny, meeny, miny, Gershon. I would like you to give me a relatively small 2-digit or 2 decimal place to decimal. None of you are named Gershon.
98.
Not a decimal. 0.12? Let's do it. 0.12, 0.12. Okay, so let's multiply them. 2 times 2 is 4, 2 times 1 is 2, add a 0, 1 times 2 is 2, 1 times 1 is 1, add them together, 4, 4, 1. How many decimal places do I need? 4. Because I have 2 here and 2 here. So 1, 2, 3, 4. And in that empty hole, I'm going to put a 0. This is a perfect square because it is 0.12 times 0.12. Now, what do these two perfect squares have in common? That is a happy coincidence. Yes, I'm not looking. Yes, true. Not what I'm looking for. What else do these two numbers have in common? Let's do another one. 3-digit decimal, or 3 place value decimal, chosen by Hayden. 0. What? 237. Okay, 7 times 7 is 9, carry the 4. 7 times 3 is 21, plus 4 is 25, carry the 2. 7 times 2 is 14, plus 2 is 16. Add a 0, get rid of these. 3 times 7 is 1 with the 2. 3 times 3 is 9, 10, 11. 3 times 2 is 6, plus 1 is 7. Oh, no, it's not done yet because Hayden gave me a silly number. 0, 0. 2 times 7 is 14, carry the 1. 2 times 3 is 6, plus 1 is 7. 2 times 2 is 4. 9, 6, 1, carry the 1, 16. There. How many decimal places do I need? 6. 3 here and 3 here. 1, 2, 3, 4, 5, 6. And in this empty hole, I'm going to put a 0. Okay, what do these 3 numbers have in common? They're all perfect squares. What else is true about them?
They don't have like whole numbers on them.
Well, that's true. That's irrelevant. I could do another one, but I don't want to because we're running out of time. No. There is something that these 3 numbers all have in common. Sorry? They all have decimals. That is true.
They all have one.
How many decimal places does this one have? How many decimal places does this one have?
Oh.
How many decimal places does
It
this one
doesn't.
have?
Oh.
Every perfect square decimal has an
Double.
even number of decimal places.
Oh.
To be a perfect square decimal, the first rule is that you have to have an even number of decimal places for a decimal to even be considered a perfect square. Okay? So, a perfect square, I'm now abbreviating, a PS decimal must have two things. One, yes, an even number of places after the decimal, and if you remove the decimal, you must have a perfect square left. Oh, cool. Then memorize it. I don't care if you write it. But if you screw it up later, I'll be like,
So like I don't have to write anything on my sheet.
if you don't write anything on your sheet, don't ever ask me for help.
Okay.
That is because I'm doing this to try and teach you, and if you actively try and avoid being taught, then I will not help you when you're struggling.
But like I don't need to write it down. I can just pay attention.
If you write nothing down, though, I will not help you because I will say, where are your notes? You'll say, oh, I didn't do them. I'm like, cool. If you don't care, why should I? I'm not going to help you then. Make an effort to engage how I'm trying to teach you. So let's go back to my question. This thing, is it a perfect square or not? It is. It has an even number of decimal places. And if I remove the decimal place, I'm left with 9. Is 9 a perfect square? Yes. So this thing is a perfect square. And the square root of 0.09 is what? Is how many decimal places does the thing that multiplies to 0.09 have to have? 1. Because it's going to multiply by itself. So it's going to multiply one decimal place is going to multiply by another 1 decimal place to give us the 2 decimal places here. So it's going to be 0 point something. What is it going to be? It's going to be 0.3. Well done. Okay. Let's take a look at some of these. How about this guy? Is that a perfect square? Yeah, it is. Square root of 1 is?
1.
Cool. How about this guy? Okay, so it's a decimal. Does it have an even number of places after the decimal? Yeah. Okay, check. First thing. Now, if we ignore the decimal, we're left with the number 404. Is 404 on the diagonal list? No, it's not. So therefore, this thing is not a perfect square. Next one, 121 over 4, square rooted. It is going to be, is that thing a perfect square? Yeah, it is. Because 121 is a perfect square, and 4 is a perfect square. So what is the square root of 121 over 4? No. What times itself is 121? 11. It is 11 over 2. Beneath it, let's write down another one. Yep. How about the square root of 18 over 8? Is that thing a perfect square, yes or no?
No.
Are you sure?
Yes.
Are you saying that because I asked the question? Okay, what's the first thing you should always do with a fraction if you can? Reduce it, simplify it. So can I reduce? 18, sorry? They're both divisible by 2. So we're going to make this thing 9 over 4. Is it a perfect square? Yeah, betcha it is. What is it?
3 over 2.
It's 3 over 2. The square root of 81 over 8, sorry, 18 over 8 is 3 over 2. Because the fraction needs to be reduced. Tricky, tricky. How about this guy here? X squared. Is x squared a perfect square? Anything squared is a perfect square. I could just write 4 as 2 squared. 4 is a perfect square. So therefore 2 squared is a perfect square. What times itself is 2 squared? 2. So what times itself is x squared? X. The square and the square root cancel. Beautiful. How about the square root of 7? No, it's not. 7 is a prime number. Okay, flip the page. One more skill I want to teach you today. Not just identifying perfect squares, but now we're going to look at estimating them. Here we go. Flip the page. When you have square roots, Hayden, can you turn around, face the front? Gabe? Hayden, are you drawing on his paper? No. You're smirking. You're barely holding it together. Don't draw on his stuff. Gabe, can you give him one more chance? Do not draw on Gabe's stuff again. Remember, you're getting report cards here in like 2 weeks. So all of these things, I'm sending grades home, and I have to send home comments with why the grades are the way they are. So, Oliver, 4 on the floor.
No.
4 on the floor. No, comments, there will be comments. You're just think about how the things you're doing are just giving me things to say. Okay, so estimating square roots. Here is how we estimate square roots. To estimate a square root, we start by trying to identify what 2 numbers that square root needs to be between. So the square root of 7 is, sorry, let's go this way. 7 is between what 2 perfect squares? 16 and? No, it's not 16 and 9. 7 is not between 16 and 9. It's between 9 and 4. So 9 goes on the top side, 4 goes on the bottom side. 7 is, the perfect squares are 4 and 9. And you can use this. Go down the diagonal. There's a number below 7 and there's a number above 7. So the square root of 7 must land somewhere between the square root of 4 and the square root of 9. The square root of 4 is, and the square root of 9 is, so the square root of 7 must land somewhere between these 2. Well, let's find out. We'll get there. So, in order to make ourselves a reasonable estimate, we need to know how far along the way 7 is between 4 and 9. So how far is it to get from 4 to 9? It is 5. There are 5 units between the number 4 and the number 9. How far is it from 4 to 7? 3. So 7 is 3/5 of the way between 4 and 9. So then our estimate is going to be that the square root of 7 is approximately equals to the squiggly equal sign. And we're going to say that it's approximately equal to 2, the lower perfect square, and 3/5, the fraction along the way that 7 is between these 2 perfect squares. Now, we don't like fractions, so we're going to start converting these things to decimals. 3/5 is what is a decimal? No calculators. Sorry? 2.6, yes. 2 and 3/5 is 2, and 3/5 is 0.6. Now, let's check how good our estimate is. Someone with a calculator, what is the square root of 7? I want all of you to get your calculators out now. I want all of you to get your calculators out now. I'll show you. Now take them back out on your calculator. Find your square root button. Some of you are going to be in different spots. The Casios have a square root button. The TI calculators, Emma, what kind of calculator do you have? Okay, so you don't have a square root button, I don't think, do you? Okay, so above, you should have a square button though, yeah? So above the square button, do you see a square root symbol in a different color?
This one?
I think you can see
You have the same calculator I do. Yes, it's the square root button. Yours should look like this. Okay, so Emma, can you find yourself the square button?
Yeah. I already know my Twitter.
Is it right there? Right above it, that's a square root sign. So to add, do you know how to access that? Yes. So this is where a whole bunch, there will be a button that matches the color. So on your white calculator, that's probably written in green. Up at the top here, there should be a green button. You push the green button after I turn the calculator on. And then you push that same button below the symbol you want, and you activate the symbol above it. So square root of 7 is? Square root of 7 is?
Not like we like it.
2.645751311. Oliver, on your calculator, if there should be like an SD button down there somewhere. If you push that, it should alternate between the exact value, so the root 7, and this decimal approximation. There's a button that'll jump back and forth between those two forms. Oliver, did you find it? Okay. Charlie, do you have a calculator? Okay. Juno, show Charlie how you're working your calculator. So look at this. Yes. Yeah. So push that button. It's the same as this one. And now push the button that has the square root symbol above it. Yeah. There you go. Now put 7 and hit equals. There you go. So now, if you take a look at what's going on here, is 2.6 a good estimate? Yeah, it's pretty good. It's 2.64. I put 2.6. We're good. Let's do another one. I will demonstrate one more, and then you're on your own to play with this stuff. There is a technique that I'm about to show you that you guys are C block. A block hated what I'm about to show you. So let me show you. They became quite uncomfortable, both with what I called it and actually playing with it. So here we go. Let's take a look at the square root of 10, shall we? The square root of 10 is between what two perfect squares? Sorry, 10 is between what two perfect squares? 9 and 16. So on the low side, we're going to put a 9. On the high side, we're going to put a 16. And we're going to square root both of them. Square root of 9 is? Square root of 16 is? So the square root of 10 must be somewhere between 3 and 4. Now, how long is the journey between 9 and 16? 7. And how far away are 9 and 10? 1. So this is going to form our estimate. Our fraction then for root 10 is going to be, we're going to say that root 10 is approximately equal to, we're going to start with the lower perfect square 3, and the fraction is now going to become 1 over 7. Now, I didn't tell you to, and in fact, I told you in no uncertain terms, we hate sevenths fractions. Don't bother memorizing it. We're not going to use it. So let's get rid of it. We are going to do what I like to call massaging the fraction. Nope. That's what we're going to call it. For some reason, the word massage is like the word moist. People are just like, ew, moist. We're going to massage the fraction. So here's how we do it. 3 and 1 over 7. We don't like 1 over 7. So what we're going to do is I'm going to find a larger equivalent fraction that makes this closer to a fraction that we can easily simplify. So if I multiply this by 2 over 2, it's going to make this thing. If I multiply by 3 over 3, that's not great. 4 over 4 we could do. I can multiply numerator and denominator. No, not like 4. Let's go back to 2. Let's go to 2, and I'll show you what I mean here. I'm going to multiply top and bottom by 2, and so this is going to become 3 and 2 over 14. Now, where we go from here, this is the massaging part. 2/14 is when I say massage the fraction, what I want you to do is nothing you're going to do is proper mathematics. But we're in the world of estimating now, and so there's a whole bunch of different estimating techniques as long as we remain close. So 2 over 14, I'm going to say that 2 over 14 is basically the same as 3 over 15 because it's close. 2 14ths and 3 15ths, they're just up by 1 in the numerator, it's just up in the denominator. So, but now 3 15ths, the reason I chose 3 15ths is because this is now easily simplifiable to a nice fraction. 3 15ths can reduce to, nope, 1 over 5. No, you're not. Don't talk about my students that way. Even if you're talking about yourself, I'm not okay with it. Don't talk about yourself being stupid. So this is going to become, after I massage the fraction, 3 and 1/5, which is a nice little decimal. 3 and 1/5 is 3.2. Yeah, fifths all go up by 0.2s. I'll zoom in, Raven, so you can see what I'm doing there. Someone with a calculator now, what is the square root of 10? Root 10 is? Juno? Done. Stop right there. If it's 3.16 and my estimate was 3.2, is that close? Yeah, does one round to the other? Yeah, we're good. So when I say massaging fractions, what you're trying to do is you're trying to push this fraction that's uncomfortable towards a fraction that we can easily simplify. The reason I say massage is because you massage, you're pushing a muscle to relax it. We're pushing a fraction so that I can reduce it to something more comfortable. I chose that word very intentionally. Okay? So what I want you to do, I want you to try, you know what? I want you to apply this to, with what little time we have left, this page here. Use the technique. Yes, you can work on the boards. You don't have a lot of time left. I would say at this point, just stay at your desks.
Yeah.
The video will get posted today. I'll do one more. Let's do one more. You know what? If you don't need one more, move to the homework. The homework is just this page. There's 8 questions. Down here, you can use a calc. Down here, no calc. Up top, you're estimating. Ruben wants one more, so let's do one more. The square root of 20. If you don't need what I'm about to do, ignore it. The square root of 20 is going to be, or 20 is between what 2 perfect squares, Ruben? 16. Between 16 and 25. So Ruben, look at your multiplication table. All these diagonals are the perfect squares. So 20 is going to be right here between 16 and 25. So this is going to be between, the square root of 16 is 4 and 5. The distance from 16 to 25 is 9. And the distance from 16 to 20 is 4. That is itself already, Ruben, a nice fraction. We're going to say that the square root of 20 is approximately equal to 4 and 4 over 9. Now, when I taught you guys fractions, I gave you a shortcut for the ninths. The ninths fractions are always the numerator repeated. So this is going to be 4.4 repeating. And if you shove, I'll do it real quick here for you. You shove the square root of 20 into your calculator. You're going to get 4.47. Now, is 4.44 close to 4.47? You bet it is. This one did not require any massaging because it itself was a nice fraction. Show, but you better get out of here. The hall's going to be crazy. Have yourself a good day. We'll see you tomorrow. There you go. Try these questions. We're going to do cubes tomorrow. This page is your homework on your mark it, set, go. If you need a multiplication sheet, you can grab it on the table on your way out. It's the diagonal. It's a squared. Color in the diagonal. Yeah. You don't need to see mine to do it. It's 1 times 1, 2 times 2, 3 times 3.
Oh, that one?
Yeah. There you go. Have a good one, guys. Try it. You guys gotta play with it. Okay. See you tomorrow. Jeff, need to spend less time on your phone in math class. Less time on your phone in